Free and bound variables. Free and bound. We take a closer look at the variables. If we look carefully, we can see that variables play two different roles in predicate logic. The meaning of "there is an x such that x e y" is that y has a neighbor. This is a property of y and may be true or false depending upon what y is. So the role of y here is that it is the vertex we have in mind, and we are in a sense free to choose the value y, bearing in mind though that the formulas may turn out to be either true or false depending upon how we choose y. The role of x in "there exists an x such that x e y" is different. Its role is to bind the quantifier "there is an x" and the formula x e y together. In fact, it does not matter which symbol we use for this binding, and it certainly does not matter what value we have hitherto given to x, as the quantifier "there exists an x" will search for a new value anyway. Occurrences. Every occurrence of a variable x in a formula, of the form "there is an x such that b," or of the form "for all x such that b," is called a bound occurrence. Occurrences which are not bound are called free. Whether an assignment S satisfies a formula in a model or not depends only on the values of S on variables that occur free in the formula. See problem 211 for an exact statement. The reason is that the quantifiers mess up anyway the values that the assignment gives to the bound variables. When we form the modified assignment, S left parenthesis a slash x, right parenthesis, it does not matter what S of x was. Whatever it was, it is now gone. For example, whether S satisfies "there is an x, left parenthesis, x e y," and "there is a y, left parenthesis, not y e x, right parenthesis, or not, depends only on S of y, not on S of x. Sentences. Some formulas have no free variables. They are called sentences. Sentences have a truth value independently of any assignment. So sentences express some property of the model itself, not a property of some predetermined elements. For all y, there is an x, left parenthesis, x e y, and there is a z, left parenthesis, not c e x, and not c equals x, right parenthesis, is a sentence that says of a graph that every vertex has a neighbor with a non-neighbor. Truth. We finally come to the fundamental concept of logic, namely the concept of truth. Physics, chemistry, geology, biology all talk about truth, but what is special about logic is that we can actually define what truth means. A sentence A is true in a structure M if some, equivalently all, see problem 211, assignment satisfies it. This is denoted M satisfies A. Otherwise, the sentence A is false in M. If a sentence A is true in a structure M, the structure M is called a model of the sentence A. Note that truth is denied by means of the auxiliary concept of satisfaction. So the primary concept is that of an assignment S satisfying a formula A in a structure M, in symbols M satisfies sub S A. And the secondary concept is that of a sentence being true in a structure M, denoted M satisfies A. It is because of the quantifiers that we cannot get away by using the concept of truth only. We need the concept of satisfaction.